No, it's Clive Roxinger here. I've got a circuit set up here. It's quite comprehensive. If I can turn the thing on, and it's actually got a switch. Now that's reading 850 millivolt at the 12 ohm resistor, 70 milliamp in the circuit. A particular part of the circuit I haven't determined yet. It's the main part of the circuit. Currents, it's in series, so it's common. So it's current supply, 1.5 volt at the 22 ohm resistor. I've now got a more advanced setup here for my gauges and getting my lab set up. This is AES, and it's quite different from standard electronics because it's more robust, and you can check current right through every part of the circuit by just changing jumpers over. You can go from series parallel, and that's a high current, which means it can handle about 20 watt, and you can run 20 watt through that and it'll still be alright. These leads unfortunately will fry, these ones are the heavier ones, and I've got these ones here which are real killers. These are beaut, these ones. They carry a huge amount of current. This is a thing I made up on my 3D printer. That's actually a music gizmo, and you can actually run one of those little power packs on that. And I made a little stand up. That's for my Arduino. Where did I put my Arduino? I got a motor working for mechatronics in Arduino. Although I haven't been able to. All I've been able to do is just basically turn angles, which is apparently what those motors do, the step motors. I was trying to get one to go vroom vroom. That's apparently a different type of motor. But this is my high current breadboard. It really means that you can run a few watts through it rather than the little breadboards. This one, you can check now the internal resistance of a battery changes. When they say internal resistance of a battery, they program you into your electronics. It took me 10 years to get back to where I was. And what they do is they drum into your head that resistance in a battery is static. It's not. The internal resistance they're talking about in a battery is a variable, but based on how much current's in the battery. And so what they term as internal resistance, when you're programmed and I did a full 12 months, they kind of make you think that it's a static resistance that's static in the battery all the time. If you do the full course, that's what you think. That's the way they program you to think. But the reality is it's not that at all. The internal resistance in the battery basically is the current falling in the battery. And because you're measuring the current to determine the internal resistance, the only thing that you're not doing is counting for thermal voltage, which you've got to take the temperature and you can work that out. I've got a formula for that. This circuit is much more advanced. This is your home lab. This is, I'll just go over here and get this thing, and I'll show you the sort of thing I'm doing. This is for students that are learning electronics, and they're trying to do it for zero cash. But just because you're doing it for no money doesn't mean it has to look like little kids' toys. Now that takes 4 batteries, that thing it's designed to. And that's your power supply. That's cool. And that's going to be on, hopefully, it's looking at this stage, it's going to be on Squarespace. And you'll be able to access the STL and G code files and make these up yourself. Be able to make all this up. I've got the designs there, but I can't get the STL and GX codes up on the internet, and also there's an incompatibility between the GX files. My little Creality printer used to use a different extension, so I have to put various formats up there, and they don't explain it. FPP, I think, is the one that I put out of mine. You've got Wavefront and all sorts of different extensions. This is something that has to be sorted out, and they bloody well don't teach you. But this is home professional. This is your 17-year-old boy who wants to learn electronics, and he wants to get right into it, man. 5 time constant, working out logs and stuff like that, running multiple meters and really getting into it, man. This is what it's all about. This is exciting, it's fun, it's challenging and a little bit complicated at times, and I've got to disconnect that. I've actually put. But this is all jumper based, so you can go from series and parallel on that. You can run up to 4 components on that, and you can go in series and parallel. You can go in series and parallel with your battery arrangements, and check the current in the batteries also. And so this is a vastly advanced system on the breadboard model. I've got my function generator here, I've got my power supply, I've got my crow there, brand new. I want myself a brand new soldering iron. I can't solder, I want one that's idiot proof. That's my 240 volt power supply for running directly from the mains that I made up. I don't know if you can see that. And I've got to make another one up that's a bit more has a bit more aesthetics. But this 3D printing, by geez, it comes in handy. What did I do with? I'm trying to find my. This is my Arduino that I got the motor going with, and I'm setting up a little test bench for that too. Very, very fine night trying to get these little pins to line up. Boy, it's hard. I've got a thing I'm drawing up there trying to work all this out. What did I do with that? I think it's at the end of the file. Just go down. Hang on there. Can't find it. Oh, there it is there. And what I'm doing is I'm actually dimensioning this all up. And all that stuff I can put on the net, but I have to find a site. I think they're going to let me on Squarespace, and I can allow you to have all these dimensions, and you can get the graphics and everything. It makes it so much easier, and you can make up your own little panels and customise them. So this 3D print, see the little gadget I made up here, that's grass that. I still haven't finished that yet, but I like that because it stands up there. Before it was just jiggling around on the bench. So this is like, this is like professional home for your 17-year-old boy. He wants to be a rocket scientist. This is what you want to be doing. Not that silly stuff with little breadboards and frying things and, yeah, oh no, you don't know what you're doing. Get something going. Get a bit of current. You get some current, you can get real motors going. What I do with my motor, you want to have a look at this thing. This is the wiper motor, I believe, off a truck. And this is 4 amp. 12 volt 4 amp, I think that is. And boy, gee, she's got some torque. You can get this stuff going, and you can do things with that. But the little electronic stuff, yeah, that's just for little babies. Shaz is gonna move up in the world. He's gonna get a job standing up. Anyway, Clive Rocksinger over.